Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all those questions one by one. Okay. Students, let us solve the next question. Question number 24. A green light is incident from water to the air-water interface. So let me just draw that. This is water and this is air. So green light is incident on water-air interface at critical angle. So this angle is critical angle. Air-water critical angle. Okay. Then select the correct statement. The entire spectrum of visible light will come out. The entire spectrum of visible light will come out of water at an angle of 90 degree to the. So critical angle means it will go like that. The spectrum of visible light whose frequency is less than that of green light will come out to the air medium, and these are the options. Basically, what it talks about is that if I incident, a green light is incident, but then it is talking about entire spectrum of visible light in all these cases. So that means if white light passes through that, then how many colors will come out? Because the different ray, different colors, in case of different colors, only if the critical angle matches this, then only it will move along this, and if the angle of incidence is greater than critical angle, it will come back to water medium. If the angle of incidence is less than critical angle for that given color, then it will come out. So which colors will come out? So first of all, let me explain this theory behind this. If in case of a prism also, we know that when white light passes through, this, the color is divided into 7 different colors, 7 different parts. So starting from V to R, somewhere here green, so different colors of light you'll get. Now this is known as visible spectrum. This is visible spectrum. Now if in case of that water and air, light travels from water to air, then only it will undergo critical or total internal reflection or critical angle is possible. So in this case, for this given media, we know that whatever is the critical angle for this water and air. Now suppose this is theta c, then this critical angle also varies with the wavelength. That is the important thing you have to understand, that critical angle varies with the wavelength. The important point is the critical angle varies with wavelength. That we'll see how. That means different colors in visual spectrum have different colors. when different colors incident, then for them, because of different wavelength, the critical angle also will be different. So there is a relation called Cauchy's relation. From Cauchy's relation, the relation is what is that relation? That the refractive index is inversely proportional to wavelength. The refractive index of the medium, in this case is water, is inversely proportional to wavelength. That means on the color whose wavelength is greater, its refractive index will be lower. And we know that for violet, the wavelength is least. So wavelength for violet is least and wavelength for red is maximum. Around 4000 and around it is 8000. So 4000 to 8000. So that means for red color and green in between. So from violet end towards the red end, the wavelength increases and the refractive index will decrease. Okay, then how this refractive index is related to this theta c critical angle? There is a relation between the critical angle and the refractive index that we'll get from here. If the ray has to move along the surface, then we also know that the critical angle and the refractive index of this medium is related with the formula that is we know that sine theta or theta c critical angle is 1 upon mu. This is how it is related. So from here, theta c is inversely proportional to mu. From here, we got inversely proportional to mu. This is and the earlier one we got mu is inversely proportional to wavelength. Okay, so that means if I write this one, 1 by mu is that is proportional to wavelength. Mu is directly proportional to 1 upon wavelength, or this can be taken that side, this can be taken this side. So 1 by mu is proportional to wavelength. So in place of 1 by mu, I will write this wavelength. So then we from these two equations, or these two relations, I will write theta c is directly proportional to lambda. So you can see here theta c is proportional to 1 by mu and 1 by mu is proportional to lambda, so theta c will be proportional to lambda. So once you get theta c is proportional to lambda, that means as we move from VI Gyur, this is the spectrum. So we know that the wavelength increases this side. Wavelength increases from violet to red. So what we are getting is that if wavelength is more, the critical angle will be more. That means in a given setup, given conditions, whatever is this critical angle, then if green light undergoes critical angle, the green light, suppose this is a green light, it undergoes critical angle. So corresponding to the wavelength of green light, whatever is the corresponding theta or theta green, I will write theta green for the critical angle of green, because this depends on this, because as this is changing, this will also change. So the critical angle for green light depends on this. Now, if green light undergoes, according to the question, the green light undergoes critical angle. That means this one like that goes like this. This is for green light. Then, if I incident with this angle increases for another color, so that means for this theta for green critical angle for green light. I suppose to understand it better, I suppose that the critical angle is 40 degree. Okay, so that undergoes critical angle, undergoes that it raises the surface. That means this is the critical angle for green light. Then this is the relation. Then if lambda increases, theta will also increase. That means what are the colors which has wavelength greater than that of green light? That would be C. These are the colors: 1, 2, 3. Yellow, orange, and red. These are the colors whose wavelength is greater. So if wavelengths are greater, then it will be critical angle will be greater. So at 40 degree, if these colors undergo critical angle, that means this undergoes critical angle. These two will undergo internal reflections, because for this color this angle is too much to come out. So this will undergo total internal reflections, TIR, probably. This undergoes. So I will rather say that these three colors BIB will undergo internal. This green goes like that, and this yellow, orange, and red. Yellow, orange, and red. These colors will come out because they have greater wavelengths. Greater wavelength means greater critical angle. So at 40 degree, they will not undergo critical angle or total internal reflections, because for those colors this angle will be more than 40, like 50. So if incident at 50, then only it will undergo this or greater than 50, then it undergoes total internal reflections. So for these rays, the total internal reflection will be greater than the critical angle for green light. Okay, so at 40 degree if you incident all the rays, then this will be the picture. These three rays will come will go under internal reflections. These grazes the surface, and orange, yellow, and red will come out of this. So there is refraction for this, reflections for this, and grazes the surface. So our question was to find which of the spectrum colors come out of the system. Now, the entire spectrum of visible light will come out? No, entire will not come out. These three will never come out. So this first option is wrong. This is not correct. Then the spectrum of visible light whose frequency is less than that of green light, frequency less than that of green light will come out. Frequency less than, so in terms of frequency, here this green light, whatever frequency it has, these three have frequencies less than the frequency of green light, because wavelengths are more, so frequency is reverse. Frequency and wavelengths are related like that. If wavelength is greater, then frequency will be less. So these are the having greater frequency than green, sorry, greater wavelength than green, so the frequency will be less. So frequencies of all these three will be less. So that will coming out. So therefore that these are the rays coming out. So therefore the spectrum of visible light whose frequency is less than that of green. So these are the colors whose frequencies are less than that of green will come out to the air medium. Yes, they are coming out of the air medium. So therefore the option 2 is the correct option. Okay. Thank you.